We love Java's use of polymorphism to override parent methods with child methods. But can you also override variables? Let's see what happens when we try. This lecture could be summarized in two thoughts. First, in Java, a child class can only override a parent class's methods. And second, if a child class tries to override a parent class's variables, it's just going to end up hiding them. And the rest of the lecture, we're just going to simply explore the implementation and behavior of these thoughts. But why do we care? This question drives two more questions. And the first question is, what makes overriding methods useful? Why do we care about that? What's the real benefit? And then what makes hiding variables, otherwise known as shadowing variables, not useful? So why would we want to avoid those? And the answer to these questions are going to be valuable if you're a student in school working on homework, knowing what to avoid for behavior-wise to implement and what you should ideally try to implement. Also, these are perfect questions for certification exams. So if you're going for a Java certification or even job interviews, these are great exam questions about the difference between overriding methods and hiding variables. And then finally, in the workplace, when doing code reviews and debugging other people's code, it's important to keep this behavior in mind. Now, this lecture assumes that you're familiar with overriding methods and you have a basic idea of polymorphism and how that applies to overriding methods. We're going to ask some questions and look at the implementation, but we do assume that you're familiar with it. Now, before we can answer the questions, we first need to look at some actual Java code. So the code that we're going to use to answer these questions is composed of two classes. The first class, animal, has an instance variable sound, and then an instance method saySound, which simply returns the variable sound's value. The other class, cat, is a child class of animal, and it has the same variable sound initialized to a different value, and then the same instance method, saySound. And these instance methods would of course be an example of overriding because they have the same input and then output signature. And these variables would be an example of variable hiding. Now, one thing is, to make this example simple, we made the variables public, which of course you wouldn't want to do in practice. The questions that we want to answer with these is specifically, what string do we get when we call the saySound from animal and cat object references? So if we have an object reference to one of these classes, what are we going to get when we call saySound? The other question that we want to collect data on is, what string do we get when we access the sound variable from the animal and cat object references? And that's why we made these public, to make this question easy to answer. So to answer these questions, we're going to create a data table. And we're going to fill out this data table by running some code. So we'll first create an animal object, assign it to an animal object reference, and then look at the results for calling saySound, and then looking at the sound variable directly. We'll do the same thing with cat. We'll create that cat object, assign it to a cat object reference, and then also call it saySound and look at its sound variable. And finally, we're going to look at a cat object that's being stored in an animal object reference and look at its saySound and sound variable. If you note here, we don't need any cast to animal because this is an upcast, since all cats are animals. So let's now switch over to the Java code and run the examples so that we can fill out the table. So here we have the Java code that we're going to use to fill out that table that we had just created. And if we expand this a little, So we can see that we have our animal class here, and then our cat class right here. And what we're going to do is we're going to create the different objects, the cat, animal, and then the animal is a cat, and we're going to print out the different values and look at what they are. So I'll set a breakpoint right here, and then I'll run the code. Okay, so, and we'll actually just increase our output window here. So we have some interesting values right here. So we can look over in the debugger, and we can see that our object reference cat has two sound variables, both meow and blah, while our animal object reference, which points to an animal object, simply has the one, blah. So it should give us some idea about what's going to be printed. So if we look at the animal say sound, and we'll step through this and see which say sound method is executed, and we step through it and we see that it's the animal's say sound. So of course it prints blah, which is what that's equal to. Now if we look at the cat, we would expect that it's going to be the cat say sound, and it is, so that we see that it says meow. Now the animal is a cat. If we look here, this shows that yes, it's an animal object reference, but it's pointing to a cat object. And when we run this, we see that this is an example of overriding because it calls the cat's object, or the cat's method, and then also prints meow. Now, let's see how this compares to the variables. So when we have the animal sound, and we go to print that, we see that it prints blah. But when we have the cat sound, as you saw, there's two different variables for it to choose from. But it's going to choose the one that is for cat, which is meow. However, when we look here for the animal is a cat, which points to a cat object, but is an animal object reference, we see that the sound variable is actually blah. So even though this is pointing to a cat object, we simply have, we get the blah, which would be this value instead of what we would like would be the meow. And we can see that this contrasts with what happened here, where we would have the printing the meow and not the blah. So if we go now to fill in the table with what we've learned, so we're back at the table, but now the table's filled in from our code example. And we can see that we look at the say sound and the sound variable, and we see that it differs when we're doing casting. And we can see that if we look down the columns, that we have the example of overriding, that whether the object of a cat is stored in a cat object reference or an animal object reference, the behavior of that method is the same, and that method will always say meow. But in contrast with variable hiding, the object for the cat will say meow for the object reference, but when that same cat object is pointed to a different object reference, which would be animal, it has a completely different value. So the behavior is no longer the same. And that's the real danger with variable hiding. So if we distill our code example and then our data table down into a few bullet points to answer those questions we had asked earlier, we find that, in summary, to answer the what makes overriding methods useful, well, It's that we can keep that same contract for inherited classes, whether we were using the animal object reference with an animal object, or the cat object reference with a cat object, or the animal object reference with a cat object. We were able to call the same method and get predictable results. And this really allows us to be able to extend and customize behavior of a method without having to modify that parent class. This is really important when you want to do arrays of things. You can have the array as that parent class, and then you can have the elements of the array assigning with the child classes so that you can perform whatever homogeneous operations you want on that array of sorting, of whatever you want to do, but then you can have the individual customization of those child classes. And whether you add more classes, more child classes, it really doesn't matter, because the algorithms that are operating on those parent classes will still stay the same. And finally, this allows us to use things like abstract classes, which you may be familiar with, to where really overriding serves as a template to force behavior when people are writing the child classes. So this is a lot of the examples or the benefits of overriding methods, and we saw that consistency in the data table. For the other question of what makes hiding variables or the shadowing variables not useful, well, we saw that the behavior was dependent on the type of object reference used to access the object, and we could see why. When we looked in the debugger, we saw that cat actually had 2 sound variables, and which one it was being accessed depended on the type of object reference. And that sort of thing can cause confusion, because depending, if you again go back to the array example, where you have an array of parent class objects, so with animal, you wouldn't necessarily get the same results if you operated on that array than if the object reference was of the type cat. So hiding variables, I can't personally think of a good use for hiding variables or shadowing variables, especially because of all the inconsistencies that it can cause. But luckily, the easy way to fix this and to avoid it is really just by making your variables private and using accessors and mutators to access them. Because when you use accessors and mutators, now you're using methods, and then you can exploit the properties of overriding instead of variable hiding.